Okay, we're back on the power supply. I got what I think is a decent heat sink. So I hope that works. If it doesn't, we'll go to plan B. And I bought this anodized L bracket. Probably would avoid this. This stupid thing is 30 bucks. Okay. So we don't want to mess it up, even though I've got two. I don't want to mess it up. So I put this graph paper on there for my screw holes. And I've got my indication for my emitter degeneration resistor and my pass transistor. And I've got 6 of them. 1, 2, 3, 4, 5, 6. Plus the control resistor, transistor. And the other 2 screw holes for the circuit board that I'm out underneath. And then I have this guy for the circuit board and this guy for the circuit board. So we have mounting for the circuit board underneath, and we're going to do that because this is thick, and it's good that it's thick because I'm going to use turret terminals in the board to mate to the transistors. I'm not just going to drill a hole in the board. I've got 20,000 turrets plus, so I want to use some turrets. So we'll mount the board to the underside. So I have to have registration for the board from the other side, and we'll align the graph paper, and this is just glue sticked on right now, so it'll come off with IPA. So we'll key to these points on the underside, and then that'll help me do the board layout. And yes, we're doing the board the old-fashioned way because it's fast. Not because it's easy, but because it's fast. It's easier to do it in AutoCAD, but I'm lazy and I don't have AutoCAD. So we're going to do it this way. And actually, no, I just bought OrCAD, so I do have OrCAD. So I could technically do it, but I'm not going to spend the time. So we're going to do it this way, and this is going to get cut off with the mill I just bought. So we just wanted to figure out how much length we needed before we're going to do our final butchering of this heatsink. We've already started butchering it. See, there's no more anodized there. So before we slaughtered it completely, and we want this to be shorter than the parent heatsink, because what's going to happen is this is going to become part of the back plate assembly of the power supply. So this needs to be set in so that the screws can go through the back panel and hold this heatsink onto the back of the power supply box. So we do need some clearance. It looks like we're going to get maybe 1/4 of an inch clearance here. Maybe 1/4 of an inch. But that should be plenty. If we have to, we'll make extra allowance for around the heatsink and make a weird looking hole. But all in all, this should work out. And of course, we'll have to heatsink grease this to here to fill all the voids. And we're going to have to figure out the whole pattern for this guy. Probably 6 screws would be plenty to hold it to here. And then I'm not sure how flat it needs to be. We can sand it a little bit. That should be fine. Sanding's fine. You don't need to fly cut it, I don't think. So that's about where we're at on the power supply. So now we're going to snap some holes and start drilling and tapping for number 4s.